want to just start with a couple of elements of kind of a big picture case that I see for silvopasture. And so one of them really briefly is related to, it's really related to paradigms about how we think about land and how we think about ecosystems and what's natural. And so, so many of you are probably familiar with the the classic model that came out of 19th century forestry and silviculture in Europe of vegetative succession. So who's heard of the idea of vegetative succession? So most people have, some people haven't. So vegetative succession is talking about the fact that plant communities change over time. And part of how they change over time is that they change the conditions that other plants are growing in. So, you know, you can see, for instance, when pastures are abandoned in Massachusetts, they will succeed in a relatively predictable sequence of plants, depending on their soils, depending on their slopes, and depending on their degree of disturbance of those soils. But so you'll often see pastures that have, you know, woody plants entering the pasture, like multiflora rose or blackberries or other brambles, or Virginia juniper coming in. And those are generally pastures where there's been bare soil scraped by overgrazing. And that made a germination spot for the seed of a bird-dispersed woody plant. Okay, so then those brambles and rose bushes and junipers end up nurserying the first wave of forest trees that germinate and grow in that old field or successional field. And then there's sequences of forest succession. The point of all this is that when forest ecology was emerging as a discipline in the 19th century, the really dominant idea was about what's called linear succession to a climax. And so the idea was that there was a climax old-growth community that was the inevitable end result of succession, and that there was a predictably linear sequence that landscapes would go through. Now, that's still a useful mental model in certain ways, but as forest ecology has gotten more complex in the 20th and 21st century, it's also clear that it's totally wrong. And it's totally wrong in some important ways, one of which is the role of disturbance. And so there was an empirical basis to the original papers about linear succession to a climax that was based on pollen core sampling from bogs in Europe. And so they had these layers of pollen accumulation from 4,000, 5,000, 6,000 years ago. And they basically said, well, okay, so before the Roman Empire, you know, before mass deforestation took place in continental Europe, here were the dominant tree species. And so they were using the pollen analysis to say, well, they were all these species that germinate in full shade and grow in full shade, and then eventually kind of replace the shade that's above them. Things like beeches and certain what we would think of as late succession old growth species. So there's been some recent historical ecology papers that have gone back and re-examined the actual pollen slides that were used in those papers in the 19th century. And we have much better technology for reading pollen samples now than we did back then. And so what they found is that there's all of these other forms of pollen that were in those samples that were not identifiable at the time. And that includes forms of pollen including things like hazelnuts and chestnuts, which were just grouped in with oaks because they were so similar, with the techniques available at the time. So, and those hazels and sweet chestnut in Europe are much earlier succession species. So if you re-examine that original data set, what you get is a picture of a historical forest matrix that's much more complex than the idea of a kind of unbroken old-growth forest. And the agents of that complexity are different forms of disturbance, right? This is the same thing that's increasingly understood about the eastern woodlands, eastern forests of North America, that they have a long history of patchiness and disturbance by a bunch of different factors. Not just wind disturbance, not just weather and climate, but also animals and people. Right? So who are some of the major the animal agents of forest disturbance in the eastern forests historically? Yeah, this one. Okay, so bison historically came as far east as probably the Allegheny Plateau in Pennsylvania, and into southern and western New York State a little bit, and occasional eruptions and migrations along the coastal grasslands through Long Island, coastal Connecticut, Cape Cod. So there's a presence throughout Appalachia. There's a historical presence of buffalo, and buffalo are these large herd animals that create an intense disturbance. They wallow, they eat a lot of vegetation, and then they don't come back for a very long time. So that's one. Who's another one?
Beaver.
Beavers, huge actor and player. And there's a whole long tangent we could go on about beavers, which I won't go on right now. But a really significant driver of a whole trophic cascade of effects in the food web. And also significantly, a little further west of here, significantly elk, who are a larger herd animal than deer, and further up north, caribou. So there are missing ecological partners in the current forests, and the current forests are regrown from a near total deforestation event in the 19th century. So all of that adds up to the fact that when we just look at our landscape as it is today, we're actually getting a tiny window on the larger span of diversity and time.
How about passenger pigeons?
Yes, passenger pigeons as well, with the rain of guano that they would produce and all the kind of damage they would do. They're opening up gaps for other species to come in. So there are some theoretical historical ecology papers that model the effect of large herbivores on forest plant diversity historically, and they're very fascinating. They're very geeky, but they're worth looking at. And the big picture takeaway that they point to is about animals in forest ecosystems, and the other side of that we can understand is the domesticated animals that we live and work with now: cows, pigs, sheep, goats. Almost none of them. Horses are really the only one who actually evolved in open grasslands. All the rest of them evolved in forests or woodlands, and so they have a relationship with woody vegetation. So this is just to paint the picture that animals and trees, the idea that they're incompatible with each other is sort of a modern mechanistic paradigm idea of things having to be separate. But the much older history is of them being very symbiotically interconnected. So that's just one piece of the case for integrating animals and trees. And another piece is the climate crisis. So I want to just head right into the thorny knot of a conversation that exists right now around animal agriculture and greenhouse gas emissions. And I want to present kind of some of the best summaries I've been able to gather from reading a bunch of the research, talking to researchers, looking at what people are finding, looking at what is confident and what is not confident, and then how silvopasture plays into that. Okay, so there's a lot of global research on the effect of managed grazing on carbon stock, on soil organic carbon. And the global average of that research is along the lines of 0.3 to 0.5 tons of carbon per acre per year. I convert all these numbers into tons per acre rather than metric tons per hectare, because most of the global research is in metric. Right? So now that's a thing that if you're looking into carbon science, you have to get very familiar with unit conversions, because there's not consistent units across studies. So 0.3 to 0.5 tons of carbon per acre per year on average. Sequestered, yes. Now, of course, you can have some that are negative, some that are much higher than that, but it averages out to really only a very slight net positive sequestration per acre. Now, a handful of studies have shown much higher average sequestration rates in the 1 to 2 tons of carbon per acre per year range from kind of intensive holistic management style plant grazing or adaptive grazing. Now that, a lot of people have seen Richard Teague's paper out of University of Texas, I believe, and there's also the Savory Institute's information. So there are clear experimental design challenges and problems with adequately studying complex grazing systems, because so much of it is manager decision-making driven. And that manager decision-making is taking into account a whole host of factors that are hard to simplify and isolate in a controlled study. So the point being, these higher-end results that these handful of studies show might well be achievable under ideal conditions. However, what does not, I think, hold up is the claim that they are achievable under all conditions on all sites by all managers. And sometimes when the claim is made that all we have to do to reverse global warming is to do holistic grazing worldwide, that's generally based on extrapolating these highest end results and applying them everywhere, which is not good science and is not a good basis for policy. So it's really not clear how consistently achievable these higher end results are. Okay. Also, methane. So when you're talking about cows in particular, you have to offset your carbon sequestration numbers by about 2.2 tons of carbon equivalent per acre per year to account for the methane emissions from the animals. Now, there's all kinds of interesting research going on about feedstocks right now with methane emissions, and seaweed as a feedstock, also, as we'll talk about a little bit, tree fodders as a feedstock. Most of those studies show reducing methane emissions by about 20 to 25% on the high end, not fully eliminating them. Now, if we add trees to pastures, if we add trees to holistic grazing systems, you get up to 2 to 2.5 tons of carbon stored per acre per year. And the trees store carbon for longer than the soil does because of the phenomenon of soil carbon saturation, where there's an equilibrium reached between emissions and sequestration after usually 20 to 30 years of improved practices. With tree systems, it's longer before you reach that kind of asymptotic equilibrium. So I'm going really sciencey here, but I went through this to illustrate how significant the difference is between adding trees to pastures and just grazing on the pastures alone in climates that are humid enough to grow trees. And that's a really important caveat. So once again, this is not saying here's the practice that will save the world and should be applied everywhere. It's saying in places where this is appropriate, you can get significantly higher rates of carbon sequestration by doing really excellent grazing and adding trees. So yeah.
Just a question about both the first bullet point and the methane one.
Yeah.
Is that taking into account that in a lot of places you're only grazing half of the year and the rest of the time you're eating stored forage?
It's a very good question about the whole life cycle analysis of where they're coming from. So I don't believe these numbers do take that into account.
So it's actually a much grimmer.
Right, like the total methane emissions may be even higher. It also depends on whether you have a cow and calf operation or whether you're just doing like a weight gain operation with the animals.
Right.
So yeah, policy making requires sifting through these complex questions of what we're actually saying, because the whole life cycle analysis is essential to feel confident in a carbon analysis. So we have to look into that more to understand how that affects these numbers. Yeah?
That first bullet point, that is total carbon sequestered, not net carbon sequestered, right?
So it is, that's right. So that has not been offsetted for methane yet. So,
right.
And it's also not taking into account emissions from equipment.
Right. Okay.
Yeah.
So when they measure methane, are they measuring methane coming out of the cow, which I know they do, or methane that is an inch above the ground or 3 feet above the ground? And I ask that question because there supposedly is impact from the methanotropes.
Right. Yeah. So let's talk about the methanotropes thing. So in around 2007, there was a paper about methanotropic bacteria. So methanotropes are bacteria who eat methane and turn into other forms that are not an intense greenhouse gas. That paper had a transposition error by a grad student in it that moved a decimal point 3 places over, and claimed that the addition of methanotropic bacteria into a field would would offset the entire methane emission of the cow herd and then some based on that transposition error. That error was then corrected in subsequent papers, but it became a talking point in some of the kind of more silver bullet oriented evangelism around carbon farming. So there are subsequent papers that have looked at the methanotrope question and have determined, again, if you have a kind of really fully operating methanotropic bacterial community, again, there may be a small percentage reduction in the total methane emitted that reaches the atmosphere and acts as a greenhouse gas, but it's more in that 10 to 20% reduction range and not 100% offset. So that's interesting. But
so what happened to the hundreds and thousands of years where there were vast herds of animals eating and atmospheric methane was steady?
Yeah. So
all that time.
I don't think it's the best use of our time to walk through the math on that right now, but the really relevant point for us to be starting from is right now, because the demand of greenhouse gas additionality that we're under is so great that it's true that there historically were large herds of methane emitting ruminants, and those have been largely replaced by cows now. And it's also true that those cows are currently emitting methane, and that matters. So, so this is the point of this. Really, is to give you the picture that holistic grazing is good and interesting, and maybe can be made better through kind of leading edge of the industry practices. And if you add trees to that, it's even more compelling in terms of carbon. Yes.
Would you take a minute to define managed grazing and holistic grazing?
Sure. So, and that's another complicated conversation in how it's researched. But I mean, basically, you could do managed grazing through a mechanical rotation of animals where you have permanent fencing and you're rotating them on a planned schedule regardless of conditions. And the more management intensive holistic grazing often involves close observation of the site conditions and adaptive decision making on when to move the animals based on what the vegetation and the weather are doing and the animal behavior. Okay, so, and then the other thing is that this practice of adding trees to pastures, pasture to silvopasture conversion, is through Project Drawdown's modeling of climate solutions, it emerged as the #1 global agricultural solution. And so here are all of the agricultural solutions in Drawdown's top 75. And obviously that's a lot of agricultural solutions. And that adds up to quite interesting numbers. But silvopasture is at the top. And this type of silvopasture, to be clear, is adding trees to pastures. It's not converting woodlands and forests to silvopastures. We will talk about that in a little bit. But the carbon farming practice is adding trees to pastures. So the majority of what I want to talk about today is how to do that in a way that actually works for a grass-based business and actually works for the management of the animals. Because there are definitely ways to do that that don't work very well and don't lead to survival of the trees and don't actually lead to the ultimate benefits to the animals and to the climate that you'd be looking for. So a lot of this is about the question of tree-based farming as a larger topic and how the heck do you make tree-based farming work? These are just a couple of images of different types of agroforestry. This is silvopasture up there. This is kind of multi-species tree intercropping up there. This is a multi-species market food forest system from the tropics here. Perennial staple tree crops that might even be grown in more of a monoculture. But one of the things about tree-based farming is that, and especially this kind of higher carbon tree-based farming, is that it's for the most part not in 4-H. It's not in the ag schools. It's not in the peer-to-peer farm networks, and it's not in the culture of agriculture in most of the United States. So it's not very surprising that most producers have a low level of confidence in it because they haven't seen it working throughout their agricultural lives, and there's not a lot of living examples of it working and contributing to profitability. So I wanted to just spend a moment doing a little exercise here for you to think about this. The issue of tree integration and how to make trees work on a farm before we dive a little further, because I think it will reveal things about what some of the challenges and restraints are around silvopasture working. So I'd love for you to see in your mind the extent of, we're going to try to make this a real example, so maybe, especially for folks who are farming or who have gardens or landscapes they manage, see the extent of systems that are under your direct management. So this is a whole under management question that holistic management asks. The systems under your direct management or that you can influence if you collaborate with people. Okay, so just see that extent of what is under your management in your mind, especially in terms of the landscape. So then, consider, what do you think the weakest link is in your current ability to develop tree-based carbon farming systems on that landscape? What's the weakest link? Like, if you decided, I want to make tree-based farming a priority, what would get in the way of that the most? Fencing. Okay. Who else sees something clearly? Yeah? Establishment. Okay, yeah. Deer. Okay, yep. Soil quality. You think that's the weakest link for you?
I got sand.
Right. Which town are you in again?
I live in Amherst, but I'm from Plymouth.
You're from Plymouth, yeah. Okay. Okay, so yeah, 40 feet of moraine sand. Interesting starting point. What else? Who sees something different?
Say knowledge base and market outlets to sustain the investment.
Okay, great. Right. The essentially the enterprise justification, of the investment. Yeah. Time, right. Who the heck has time for that? Yeah. Okay. So just other people, things you've already heard match what you were seeing. Yeah, so these are all real weakest links. These are all real restraints on the ability to integrate trees. Now, if you look at the big picture of, and again, like agricultural lands, as these folks know well, agricultural lands are only one of the types of lands that have a big role to play in solving climate change. So, but if we're talking about carbon sequestration on agricultural lands, in humid climates, the tree-based systems so far outperform the non-tree-based systems in terms of carbon storage that it's like talking about two different topics. They're far, far more carbon sequestering than, which doesn't mean that non-tree-based systems aren't good and important and worth improving and worth developing, but it's just saying if you're talking about carbon, the game is really in adding trees in humid climates especially. So if that's where we're starting from, then this question of what restrains our ability to add trees to farms is a really important one. And this is where the lack of a tree-based farming culture and history in the U.S. really gets in our way, because we don't have the knowledge and technical assistance base spread all throughout the country on this. It's like in little tiny pockets and patches. So what that means, and I'm quite convinced of this from working with a lot of farm businesses over a lot of years, is that it means two things. One of them, it means that there needs to be a really deeply motivating desire on the part of the producer to be working towards being at the leading edge of the industry. In other words, you have to really want something that is outside of what's easy to do in order to be able to do it successfully. And that the longer term, the cost of that business transition is not bearable by the farmer alone. That's going to require kind of, climate retrofit financing packages, essentially. It's going to require funding and financing ecosystems that don't currently exist yet. And so there's people who have ideas about how to do that. Some of them involve environmental markets. Some of them involve just pools of funding that have not been collected yet. But I just wanted to give you that picture that there's the deep motivation and desire of the producer, but then there's also the support structures that would help them actually do that. And there's going to require people sticking their neck out and going out on branches, and it's very understandable if any one individual business can't do that. So we're not necessarily in a time when the widespread adoption of tree-based systems by every producer is actually ready to happen. We're in a time when the funding and financing and technical assistance to enable that to happen needs to be gathered together, and high visibility projects that show people how it works need to be assembled. So that's just a little bit of kind of theory of change strategy about where I think we are with agroforestry. So, more on that. Okay, how does silvopasture work? There's some core variables to silvopasture, and one of them is shade. So, here is a little bit of the research on some of the effects of shade on animal health and the productivity of animal systems. So, these are primarily beef cattle examples. There's some good research out of Europe on dairy systems that I'm starting to dig into that I don't have good results out of yet. But just on the beef cattle side, I think you can see, those of you who are working on dairy, how it translates into dairy systems. So, comparing weight gain on beef steers with access to shade compared to those with no access to shade, they gained between 0.9 and 1.25 additional pounds per day when they had access to shade during the growing season in one study in Kentucky. And, you know, I think it makes sense if you imagine working and living in the open sun all day in the summer without the biological ability to sweat. You might get pretty hot and overburdened too, and we would naturally go towards the shade if it were ever available. So as temperatures are rising with climate change, it becomes more and more important to have shade access. So cattle provided with shade had conception rates of 44% in a study in Florida compared to cattle with no access to shade who had conception rates of 25%. So that's a big difference economically. That's a big difference in terms of just the health and ability to live that those animals are demonstrating. And shade increased overall pregnancy rates of cattle by nearly 40% in a study in Missouri. So one of the big, you could think of it as the primary benefit for the animal farmer. You could think of it as a co-benefit if you're focusing on carbon. But one of the big central benefits of silvopasture is producing a shade environment that the animals can use and access year-round when they're on grass. And now the thing about living in a cold climate, and even a cold humid climate, is it takes a long time to grow the shade, right? So we don't have the tropical growth rates where you can get a full canopy tree in 4 or 5 years. We are on a much slower program than that. So that's one of the challenges of silvopasture in cold climates, is how long it takes to establish that shade environment. The other thing is that it's important to not have too few trees. So you have to have enough trees that the animals' impact from going towards the shade is not unduly concentrated on those handful of individuals, and then you lose the tree through soil compaction, through branch and trunk rubbing, through all those kinds of things. I have so many times when I've been to farms that have established silvopastures in their pastures on a hot sunny day, every animal is under the shade of one of the trees. If they're not actively moving between foraging areas. So it's important to not have too few trees. You also don't want to have too many trees, because beyond a certain point, the density of shade will reduce the quality of the forage significantly, because you'll actually get vegetative succession, where it will change to a much more shade-tolerant mix of plants in the understory, most of which have very low forage quality. So we'll talk a little more about the difference between silvopasture and forest grazing. But one of the big issues with forest grazing is that there's nothing for the animals to eat in the forest. Or it's very low quality, so they end up damaging the forest and not even getting very much nutrition from it. So you have to have enough trees that they don't damage the trees, but not so many trees that you lose the forage resource. We'll get to some specifics on that. So here's a range of a couple slides here to help people visualize what we're talking about with these canopy coverage levels. So this is about a 50% canopy cover. So this is a bird's eye view of just looking at tree cover. This is about a 50% level of cover here. This is about a 25% level of cover. This is about a 10% level of cover. around 10%, definitely below 10%, you're hitting not enough trees in most systems. This is usually the range of the sweet spot, and usually it's more between 50 and 25% in terms of the sufficient access to shade and not concentrating animal impacts too much. Above 50%, you're usually getting too shady. Now, there are more quantitative ways of looking at this from a forestry perspective that are based on what's called basal area. And we'll talk about that in a little bit also. But just as a rough idea of what we're talking about, this is about the range we're talking about. Here's another view of it. So on the left, these are trees. This is a 1 acre square, okay? And these are trees of 25-foot canopies, and they have 60-foot spacing. Now, some of the silvopasture systems that we've been experimenting with and finding work the best have even wider row spacing than that, but closer spacing between the trees, which we'll talk about. But just for you to get a sense of, in an orchard-type layout, this gives you like 13, 14, 15 trees per acre, and you're still at 15% canopy cover. So that's around the low end of how much shade is really workable. This is, we're going down from 60-foot spacing here to 40-foot spacing here. We're up to 30 to 35 trees per acre, and we're in the 30 to 40% canopy cover range. So, that's a very sweet range to be in terms of the animal shade access. And now, well, more on that later, on the implications of spacing for how the trees grow, because that's a really important part of it too. Here is another way to think about canopy cover. So these are alley systems. And in a little bit, I'm going to make an argument for alley systems as the way to add trees to pastures that is most frequently the most successful. So this is 25-foot canopies, and they are at 25-foot spacing in the alley, but it's an 80-foot row spacing between the tree rows. This gets you to about 20 to 25% canopy cover on a per acre basis, and you have around approximately 20 trees per acre. We're finding this 80-foot row spacing is a valuable one for a number of reasons, which we'll talk a little more about. Here's a 60-foot row spacing of the same thing, and here's a 40-foot row spacing with the same size tree. Partly I'm wanting to just give you some of these visual images because for people who haven't worked with trees on farms, who don't have an orcharding background, it can be like, Cyrillic to try to think about how do you incorporate trees into a pasture. Here's some examples of how it can end up looking on the ground. More to come on these. Forages are another big variable. So, here are just some very rough estimates of the preferred forage percentages between cattle, sheep, and goats. So cattle prefer 70% grass diet, 20% forbs, only 10% woody. Sheep, more like 40 grass, 40 forbs as in non-grass herbaceous plants. 20% woody. Goats, 10% grass, 40% forbs, 50% woody. So that means that the animal species that you're grazing matters a lot for the silvopasture system, and it also matters for how they're going to interact with the trees. So goats are one of the more difficult animals to make work in silvopasture systems, even though you think, they eat woody ground, it's so great, but they are much more aggressive at pressuring the trees to an older age than sheep or even cows generally are, because they eat cambium so readily. So generally with goat systems, you have to fence and protect the trees for more intensively and for longer than you do with cows or sheep. Okay, so rotations. I don't need to say too much about this other than that, excellent rotational grazing is mandatory for silvopasture. It's not optional because of the impacts that accumulate on the trees and the fact that you then lose the quality of the investment in the trees. So there's not really even a point to considering silvopasture if you're not already doing good rotational grazing. Okay, so a couple different silvopasture systems. And again, I want to focus, we'll talk a little bit about forest silvopasture. But I want to focus on pasture to silvopasture here. So this is a very mature alder silvopasture from Mexico. Interestingly, they're using nitrogen-fixing trees there. They do that a lot in the tropics for a bunch of reasons. Here is a walnut silvopasture system in Missouri. There's that clustering under the shade that you see a lot of the time. Those are both pretty mature systems. So how do you get them there? Well, again, we've talked about these spacings. Sometimes I think about this in terms of a woodland versus a savanna spacing. So in a woodland spacing, you usually have 40 to 60% canopy cover. You usually have about 50 to 200 trees per acre. And you really can only grow cool season grasses, because this is a level of shade where warm season grasses fall out. And the interesting thing about this range of canopy covers, and for those who are fluent in silviculturese, this is, what we're talking about here is a 40 to 65 or maybe 70 square feet of basal area per acre range. In that range, and especially on the higher end of that range, especially in the 50 to 70 square feet of basal area per acre, you can actually grow timber bowls. So you can actually co-produce timber with a grazing sward. And that's another co-benefit of silvopasture, is the intensification of production by growing a tree crop on the same ground as you're grazing. You lose some growing area to the trees, which we'll talk about with a case study, but you gain overall yield and profitability through the timber harvest. But again, that's a woodland space. Most of the tree fodder systems and most of the kind of adding trees to pasture systems are in savanna-like, more savanna-like spacing, where you can have both cool and warm season grasses growing. And generally, you're not growing timber in those, with one exception, which we'll talk about. But generally, you're not growing timber. You're growing leaf and stem fodder. You're growing tree fodders, and you're growing, potentially, you're growing an orchard. You have to guard the trees. That seems obvious. Usually, you need your rotational fencing to be involved in addition to tree protection. If people are interested, we can go into some more detail on how to protect the trees. On average, this is the tree protection. If we assume you already have a grazing fencing system that you're using, the additional tree protection might be another $5 to $10 per tree, just as you're thinking about it. And we could talk through a whole enterprise budget of planting some of these trees if that's helpful. You also have to do a lot of maintenance. Not a lot, but you have to do some maintenance in the first couple of years. You have to, generally, until you can allow the animals access to the trees, you have to do the vegetation control around their base in that strip of land that the animals are creating. And you also have to maintain the tree protection against both deer and voles because of the winter vole damage on the lower cambium under the snow. Any questions on any of that? Just like really high level things about how to add trees to a grazing system? Okay, we're going to look at some things around establishment now. So, so what I don't love about this drawing is that it shows the fencing so far away from the tree. A more accurate drawing would have the fencing much closer to the tree on both sides. But this gives you the idea that your rotational paddock is between the rows of trees you're establishing. So you establish the row, and you have a width. The alley width is such that it's logical for your grazing. So, for instance, usually we've found that at least with sheep and cows, I don't know so much about goats, but at least with sheep and cows, there's something, and people probably have their own experiences with this, but there's something about the narrowness of certain grazing blocks that the animals aren't totally relaxed about. So once you get below like 35 to 40 foot width of a fencing unit, they don't fully utilize the forage. They're a little antsy. They're not as happy. So generally, we're recommending that people not go narrower than 40 foot spacing at first. More on that in a minute. And then you have these trees with their tree tubes or their individual fencing ready to establish. So again, this might be the first 5 years where these trees are growing to the point where they have a thick enough bark, they're strong enough in their root growth that they're not going to be pushed over or eaten by the livestock. Now, keep your eyes on where these trees are here. This is year 6 to 10. Okay? So the bigger trees here are the ones that were small in the first 5 years. They've grown bigger, and they've grown bigger to the point that you can give the animals access to them. So now the rotational paddock includes those trees, and there's a new strip of trees established in between the two. So the nice thing about the 80-foot spacing is that you can have another row at 40 feet in the middle and still keep that 40-foot spacing. Or at a 40-foot spacing, you can let the trees grow longer, and then you let them grow to the point that animals can interact with them, and then you add the intermediate row. So eventually, often, you're doubling the density of the trees eventually, but you're not doing it all in 1 year. You're essentially establishing every other row first. Any questions about this kind of establishment concept? It's not the only way to do it, but this is one way that's proven successful. Okay. Let's talk about species of trees. What kinds of trees would we be adding to our pastures? All right. I don't know if I'm supposed to say a Hail Mary here, but I'm going to talk about black locust. Okay, so black locust is maybe the number one agroforestry tree in the northeastern and mid-Atlantic U.S. The multifunctionality of this tree is mind-blowing. And there's a couple things that make it really, really applicable to silvopasture systems. So I'm saying this fully knowing that this tree is illegal in Massachusetts. And I'm arguing that it shouldn't be, and that that's actually a deep misunderstanding of our ecological history to classify this tree as an invasive species. So one of the things that is very valuable about black locust is that it is the only small diameter marketable timber that grows in this climate. So you can cut it at 8 to 12 years of age for fence post size timber. And that's not true of any other timber species. So it has an economic role it can play that very few other trees can. It's also very fast growing. It's nitrogen fixing. It is a very exceptional nectary producer for bees. And it's an excellent tree fodder. So in New York, where black locust is widely used for a bunch of things, there are people doing sheep silvopastures who their whole pasture is dried up in a drought, but they still have green fodder on the black locust trees because they're also so drought tolerant. Right? So we'll talk a little bit more about tree fodders as a concept in a minute. This is just an image of the size that some of the larger black locust fence post bowls end up getting to. Okay, so black locust is one. Another one is, so who's this? Poplars on the left, and then who's out on the right? Willows, yeah. So the whole Populaceae, the whole willow poplar family is a source of really good genetics for tree fodders. And so you might start to notice some of the things we're looking for. We're looking for growth rate. We're looking for leaf palatability and leaf nutrition, so that they can double purpose as a tree fodder. We're looking for site suitability and ability to grow on a wide variety of sites. And poplars, especially, and also willows, they fit a lot of those criteria. So the hybrid poplars are one of the highest growth rate trees in this region. A lot of those genetics can hit 4 to 6 feet of height gain per year. And height gain is really valuable for a tree fodder. So let's talk about this tree fodders thing for a second. Actually, I'm going to show you one more species, and then we'll get into it. Who's this one? And what the heck is going on in this picture? Not Catalpa. Not chestnut. It's mulberry. So mulberry is one of the most widely used tree fodders in the world. And it's not the fruits, it's the leaves, because of their protein content and because of how readily they resprout from being coppiced or pollarded. So let's talk about this idea of tree hay. So this is one of these things that has this deep, rich, complex agricultural history all over the world and is totally forgotten in the U.S. And part of why it was forgotten, the classic image from Italy, for instance, is that the really rich farmers on the best soil grew wheat. And then the farmers on the hillsides with the slightly worse soil grew corn. And then the really poor farmers in the mountains grew chestnuts. Okay? So a lot of these tree-based agricultures have been associated with poverty. And they've been associated with the people who were pushed out of the best land. And the same is true with this tree hay practice. So there's a lovely book that just came out. It's kind of an airport book, but there's a book about coppice and pollarding. By what's the guy's name? He wrote William Bryant Logan. He wrote the book about oak trees. So he has a book about coppicing now, and he talks about this use of tree leaves and stems as a hay source for livestock going back thousands and thousands of years. There's all these intricate techniques for how you bundle the tree hay together and how you carry it on your back. There's certain knots that you use for that. It's really amazing. But so, what is the management? How do you produce and store branches as an animal fodder? And how on earth would you even do that? So it's usually through this practice called pollarding. So people have heard of coppicing, where a tree is cut all the way down to the ground. Pollarding is it's cut higher than that. And generally the pollard is done just above animal browse height. So it might be done at 5 feet or 6 feet or 7 feet, depending on who you're working with. But it's cut at that point, and then so sometimes you come through and do the pollard and just hang all the hay down right on the tree, and so the animals can come feed on it directly. And sometimes you bundle it and store it. So there's fresh uses and dry uses. There's almost no technical information about how to do this in the United States. So this is not a practice that has the confidence of decades of extension and NRCS experience behind it, but it's a practice that has the confidence of thousands of years of peasant agriculture behind it. We just have to relearn it somehow. So there was actually a SARE grant that someone did in Maine 3 years ago on tree fodders and tree hay. Very fascinating to read through. They were experimenting with it more in a woodland setting in a lot of cases. But a lot of the uses for this are about what trees you plant into the pasture are trees that you can pollard for tree hay. So that you're intensifying the fodder production and you're making up some of the grass that you're temporarily losing by establishing the trees. Any questions about that? Or any of that? Yeah?
What does that sound like a honey locust versus a black locust?
You are reading my mind because the very next tree I want to talk about is honey locust. Okay, so what is the difference between honey locust and black locust? Who knows a few things about honey locust versus black locust?
Thorns?
Yeah, honey locust there are thornless honey locusts. But honey locust has about 1.5 inch long thorns on it. Black locust thorns are very small, 1/2 inch less. What else is different? Yeah, these big pods. Black locust pods are real thin. Honey locust pods are big and they have a sugary starch in them, kind of a little bit like Kentucky coffee tree, but sweeter. And so the major fodder product from honey locust is the pods. It's not the leaves. They're high sugar. They're somewhat high protein. There have been studies showing in intensive silvopasture systems with honey locust as the main kind of overstory, the honey locust adding up to a ton of fodder per acre per year. So that's promising. Honey locust also does not fix nitrogen. So it's in this class of southern Appalachian leguminous trees that don't fix nitrogen, or they only do under certain circumstances, along with things like redbud and the yellow tree and a few other of those southern legumes. The other thing about honey locust is it gets real tall and real big. And so you can have a multi-strata system sometimes where the honey locust is the overstory and there's still trees under it, because it also doesn't cast shade very densely. And it leaves out quite late in the year, so you get an early spring of more light penetration. Okay, so we talked about black locust, we talked about honey locust, we talked about poplar, we talked about willow, we talked about mulberry. Those 5 are the trees that we're sort of currently most confident in terms of adding a tree fodder to a pasture. We'll talk in a little bit about silvopasturing in orchards and how that can work. So there's a whole other category of trees where the tree is the economic crop. But in terms of the tree as a fodder source for the animals, those 5 are what we're most confident in. A little further south, and some of you might live in, I mean, even on Cape Cod potentially, I would add American persimmon to that list. And the fodder source there is fruit drop. And it's late season fruit drop, where it kind of fills a niche in the year. The problem up this far north, or at least in zone 5 and 6, is that the growth rate of the persimmon is pretty low. Very, very slow growing. But once you get into zone 7, they're a lot more fast growing. Yeah?
What about winter fodder? Do we get winter fodder from any of these trees?
Yeah, so the tree hay can be stored for the winter. And when it's done, usually it's bundled in extremely tight, dense bundles to preserve more of the chlorophyll. And so you still get semi-green leaves and branches in the middle of those bundles. What's that?
Is it dry?
It's dry, yeah. Yeah. Not so much the pod and fruit fodders. Those are eaten off the ground. Yeah.
Question connected to tree fodder, perhaps, is my concern with the shade on a production dairy is if the cows would just hang out in the shade and not eat, and their milk production would go down. Mm-hmm. And so I'm wondering if there, of any research that's been done on what happens to milk production in a silvopasture system, and then how tree fodder might relate to that. I'm imagining like 2 cows would eat all of the fodder off of a tree that they could reach in like a day, but maybe not.
Right. Well, in a lot of cases, you're not letting the cows eat from the tree directly. It's either dropping or you're cutting it yourself and then dropping it.
Right.
And I mean, I think you would probably use a lot of the things that you use to manage animal movement, like the placement of watering sources, the placement of salt, thinking about the wind direction, all the things you use to kind of help an animal use an area evenly in ordinary grass-based management. The importance of those things might be heightened by the temptation of the shade. I think the other thing is once you get an environment where there's a relatively consistent amount of shade available, that would drop as well.
Yeah.
But I think you're right that early on there may be some increased management challenges with getting them to adapt to still grazing while they have the shade access. Yeah, that's a good question. Yeah.
Is it common to use a combination of those species, or was stick with one?
It's a great question. So you can definitely use a combination. However, from a management perspective, you generally want to plant. So, for instance, if we were looking at those alleys that we were talking about, and you imagine one of those alleys that has all 5 of these species in it, the management would be very challenging. Generally, you want to have an alley that's all one species, or a block within an alley that's all one species. But the alleys can have different species themselves, and I think the honey locust works as an overstory that can be interplanted with other things. But because of their growth rates are different and their canopy sizes are different, a lot of the other ones I would generally treat more in a block, with our level of knowledge at this point. Yeah?
Are you pollarding all of them, some of them?
Depends on what you want to do, right? So when you pollard, you get more tree fodder production and less shade, right? So it may relate to the like you were kind of asking about. It may relate to the layout of your pastures and where you want to concentrate. Like for instance, the droughtiest pastures might be the most important ones to have a on-site tree fodder resource. Pastures that are more productive during drought, the shade might be the more important thing.
And do these species all respond well to pollarding? Do they grow back quick?
They do, and that's part of why we feel some level of confidence in them. I mean, an I'm interested also in red maple. I'm interested in elms. I mean, there's a lot of things I'm interested in, but we don't have a lot of like living examples of them yet, at least on this continent. Now, another thing people do a lot is pines. And they do pines as a timber plantation with grazing. That's a pretty common practice in parts of the South, actually, and even parts of the dry West, where you'll thin a timber plantation to a silvopasture spacing and then graze it for years until you take out the rest of the trees. It's kind of a sort of successional practice more than a long-term thing. People do that. Okay, so let's talk for a short bit about forest to silvopasture conversions. Because I know some people had questions about this. Okay, there's basically 4 things you have to do. You have to do a really quality assessment of your forest stand. You have to do the silvicultural planning of how you're going to, because the thing to picture here is that forest conditions are not good grazing conditions. The forage quality is really low. And so because of that, you have to do a significant modification of the forest in order to create a silvopasture. And that is a relatively permanent modification. So just to give you an idea of the planning process, and then we'll talk about the caveats and why you might not want to do it. So you do your forest stand assessment to understand what you got. You do a silvicultural planning to understand how to remove the trees. Then you have to thin to a woodland spacing that will allow for forages to establish. And usually that's 40 to 65 square feet of basal area per acre. A proxy is taking out half the trees, but it's not always that. You have to look at your actual density and whether that's sufficient or too much. And then you have to do forage establishment. So this is a multi-year process. It doesn't happen in one season. You can sometimes get animals into one of these woodland silvopastures towards the end of the second year after you start, once you've gotten a really dense forage sward going. But you don't want to put them in before that because you don't want to set back the establishment of the perennial forages. Yeah?
Wouldn't you want to graze off the suckers from the trees that you're trying to kill?
Yes, thank you. That is that's a little cheat code in it a little bit, where you can actually use the animals as part of the clearing process right at the beginning. But you want to do that before you start the forage establishment. So you can do some pass-through grazing after the thinning, and potentially even after the resprouting has started. But once you need to let the forages really get some roots going before you start grazing, just like seeding any new pasture. Okay, here's some caveats about converting forest stands to silvopastures that are pretty important. So one of them is that this is not a carbon farming practice. Mm-hmm. You are losing carbon when you do this. Now there's some scenarios where if you had a really high quality stand of timber that you could use for very permanent things, you might be able to sequester a bunch of that carbon in furniture and buildings and tools and things like that. But usually those aren't the stands we're doing silvopasture in. We're usually doing silvopasture in the stands that are, somewhat hopeless from a silvicultural perspective. So it's an interesting practice. It's a farm viability supporting practice. In many cases, it's not a carbon farming practice. And when Drawdown talks about silvopasture on its list, it is not referring to this. It's referring to adding trees to pastures. Okay, now the other thing is that this produces forest fragmentation. It opens up interiority the other kind of interiority in the forest in a way that reduces the closed canopy interiority and in a way that gives access to nest predator animals to those forest interior bird nests. So the kind of short and sweet of it is that we're really encouraging people to really only consider this on the edges of existing fields rather than opening up whole new fields in the middle of the forest. Because that is not that different from a forest fragmenting housing development going into the middle of the forest in terms of the effects on canopy structure. There are animal impacts on the forest trees and on the understory. So this is a relatively permanent change in the vegetation community. And in particular, it's a change in the understory community. So you want to really think about what is the understory that you're replacing, and do you want to be replacing it? So what we're often finding is that the sites that make the most sense for this forest silvopasture conversion are ones that are already highly impacted. So they might be highly impacted by introduced woody species like barberry or bittersweet or the honeysuckle shrub, or any of those ones who spread so readily, they might be highly impacted by those, and you might be looking at a future of constant mechanical or chemical management to deal with those if you're trying to deal with them, versus allowing the grazing pressure to deal with them. And even that will require an initial round of understory management where you, at minimum, cut back and in some cases pull out some of those species. Also, poorly formed timber stands, so timber stands that have been high-graded repeatedly, and that high grading has selected for trees with a low genetic suitability for their site. Those are stands that, if the long-term forest management would point to a reset on succession anyway, this would be one way to do it, in a way that was kind of part of an overall farm plan. And also old evergreen plantations is another one, where during the red pine craze of the 70s, the Scotch pine craze up in the Adirondacks in Vermont, places that never really became what people thought they would be, which is a concern I have about the black walnut thing currently, by the way. You're essentially gambling on what the veneer market is going to be 30 years from now, and how on earth would you know that? But it is one possible silvicultural pathway for these old evergreen plantations. Yeah.
What about manure management? Is this something you have to think about?
Well, or
do the animals just take care of that?
Yeah, if you're doing effective grass management and effective rotations, there's not a significant manure concentration because the manure is breaking down aerobically. The problem with manure in livestock systems is when the manure is concentrated enough that it breaks down anaerobically, and then you also get a concentration of nitrates and phosphates that can move in, overland water events through storms and things like that. So, you always want to think about what is the nutrient runoff implication of having animals near bodies of water. If you have a perennially vegetated buffer between the animals and a body of water, there's minimal nutrient runoff in general, except in really large storms. And so you want to think about all the things you're thinking about animal agriculture also with this. Yeah. Okay, so we talked about the difference between silvopasture and forest grazing. It's not just putting animals in the woods. Couple specialized applications. Let's talk about orchard grazing for a second. So, orchard grazing, you may have noticed there's a lot of grass in a lot of orchards, and you may have noticed there's a lot of mowing to do of that grass. And also a lot of orchards have fairly mature trees that aren't so at risk of their bark being stripped off by sheep, maybe by goats, you never know. So, there's been a lot of successful sheep, in particular, integrations into orchard systems. A couple things that we've learned: you still have to mow generally because the timing of basically it's rare that you will be exactly ready to go back to the beginning of your rotation when the grass is most ready to be eaten. So generally, there's still a bit of mowing to do, and also if you are organic certified, there are rules in the organic standard about contact between manure and the ground under an orchard, with any fruit that might drop to the ground and be picked up off the ground. And those rules, depending on what state you're in, they point to a 60 or even a 90-day buffer period where you can't have any manure application. And the way they're generally written is they don't make any distinction between raw manure versus composted manure versus manure straight out of an animal. So if you are complying with the organic standard, you generally have to have more land than just your orchard to graze on, because you have to be able to have the animals somewhere while your fruit is ripening. And you can do a late season graze after the harvest has happened. But a specific kind of use case of orchard grazing that is very interesting is some trials that are being done around chestnut silvopasture right now. So there's a small 1-acre trial system of this at the UMass Ag Learning Center in Amherst, if anyone's ever been there, that I've worked some with. We actually just planned a windbreak there this year. It was really good. And then this is my buddy Russell, who's some of you probably know. But so he's converting 20 acres of a corn and soy rotation in Rensselaer County, New York, into a chestnut sheep silvopasture. So he's planting the chestnuts on, I think he's got them on 40-foot row spacing. And then he's got a livestock partner who is running a lamb operation. They're seeding to permanent pasture, and they're going to do a lamb operation moving in between the chestnut rows. So that's one of the bigger kind of carbon additionality and nutrient runoff reduction additionality land use conversions that you're likely to see around here, other than just reforesting a place, is corn and soy on a sloping site into all permanent pasture with chestnuts. That's pretty good. So then there's also John Niger, who's here at the conference. Actually, he and Russell are presenting together right now. He's got a chestnut poultry silvopasture system that he's developing in Sunderland, Mass, along the Connecticut River. So the thing about chestnuts that makes them interesting from a silvopasture perspective is that they're really low maintenance. So they, the challenge with fruit obviously is the labor and the pest management, and there's much, much less of that with Chinese chestnuts. So it can fit in well with just what the cycle of work is in a grazing system. Any questions about this the orchard and chestnut applications before we move on? Okay.
This is Chinese chestnut primarily for fodder and animal consumption?
No, it's for a nut crop.
Okay.
It's for a nut crop. Yeah. Okay. This is the one close enough to commercially viable nut crop right now in New England for people to go for it. Hazels are not even close, which is a topic for another time. But okay, so this is a practice that is being used in South America a lot and not so much in the U.S. yet. It's called intensive silvopasture. So intensive silvopasture is where you have overstory of trees, and then you also have a very high density shrub fodder planting in the understory, and you have a grass forage. We're talking 1,000 to 10,000 fodder shrubs per acre. They're generally all nitrogen fixing. Intense short grazing periods with pretty long rest periods. And all the research on this system shows improved meat production, improved bird and insect biodiversity, and significantly improved carbon storage compared to just standard silvopasture. So it's basically silvopasture with fodder banks everywhere in the understory plus grass. Very expensive to establish, and also in this climate we don't have the shrubs yet. We don't have the right shrub fodders yet. But just for you to know what's happening globally around this practice, it's developing into some very intensive systems. I'm going to skip over this next one because I want to show you this, because this is related to some questions people were talking about their home gardens. So in the humid tropics, it's a very, very standard for people's home garden livestock systems to include tree fodders for their animals. And sometimes those are in the form of living hedges and living fences. Sometimes they're in the form of a grove of fodder trees that the animals go in at the time of year when the fruit is dropping. But generally on these small 2 to 5 acre diversified tropical home gardens, there are, in addition to all the fruits and nuts and everything that we think of, there is also animals, and there are leaf fodders for the animals, and sometimes fruit fodders also. In cold climates, poultry and chickens actually can fit fairly well into some cold climate, permaculture forest garden type systems. It's very dependent on what your trees are and what your animals are and how you're using them. Usually, we haven't seen it work that well in cold climates with, home goat and sheep systems yet, mostly because we don't have the rate of tree fodder production to work with that they do in the humid tropics. But it does seem to work pretty well with chickens if you have a kind of a perennial chicken yard that has some shade resources in it. And it can fit in well with a variety of perennials like that. This is another application that's very interesting, which is outdoor living barns. So this is where you have a dense stand of evergreens that you overwinter particularly hardy animals in. This is Scottish Highland cattle, certain sheep breeds can handle that. It can be a use for old Christmas tree plantations. It can be a use for windbreaks, a multifunctional use for windbreaks. And again, pretty widely done in Europe, and especially in Scandinavia, not widely done in the U.S. There's basically no peer-reviewed literature about this. But it is a thing people do, and it is another application of integrating animals with trees, so I wanted to mention it. And then I'm going to, I'll just mention this quickly. Pass-through forest grazing is when you are moving animals through very, very quickly through an unmanaged forest stand to graze on fruit or nut drop, to graze on mass drop. And the key thing there is speed. So it's, people think about pigs in the woods, feeding pigs acorns, but the acorns are only available for about a week a year. And you have to think about what you're feeding the pigs, the other 7 months of the growing season. Also, after windstorms, there's often access to some really tender, nutritious upper branch leaves. And you'll always see the deer moving around and accessing those. So that's another time you can bring ruminants into the forest. Again, fast. Historically, there were these kind of like wandering pig peddlers in the South that you probably know about. And what they would do is, and this is like 1700s, 1800s.
Drovers.
Yeah, they were the pig drovers, right? They would travel with pig herds all the way across the deep South. And they would move with the seasons up and down elevation, north and south, east and west, to where the mast was at that time of year. And they would extend from the Carolinas all the way out to Texas, like that, and back. Pecan groves, oak stands, fruit stands, early season, late season. So that's a really wild, cool thing. But again, vast territory they're moving across. Same with the Spanish Dehesa systems, the pig silvopasture in Portugal and Spain. Huge territories the pigs are moving over, very frequent rotations. There's a whole conversation that Steve Gabriel and I and some other folks have been having about what does it really look like to have pigs in the landscape in a way that makes any real sense long term. Just because the amount of damage they do to soils is so great. And so, one thing we're speculating is like, more land, more rotations, and maybe longer term ruminants are a more sustainable meat source than pork. Even though pork is, much more kind of commonly everyday eaten than lamb, the sustainable management of sheep is much easier to wrap your head around than the sustainable management of pigs. So, just a curiosity that I'm having. Obviously, the markets don't agree with that currently. This is two other just kind of unique case examples. This is a forest farming silvopasture system where so you got a sugar stand, and then you've got your shiitake mushroom yard in the sugar stand, because why not? And then you have a moat of ducks around your shiitake mushroom yard. And the reason for the moat of ducks is to prevent any slugs from getting into the shiitake mushrooms. That's one of the big economic losses of shiitake production. The ducks basically, this system in the trial, they did a Sarah grant on this, one study, but what they showed was economic losses to slugs went down to 0 with the duck moat. So, obviously you need feed, you need other things, but this is a thing people do and have done, and this is one of my favorite ones. So this is vineyard grazing. So Vitipasture. So this was developed first in New Zealand, and then it's being done in California in a few places. The most fascinating thing about this is that, so my buddy Kelly Melville, who's the ranch manager at Hycena's Ranch, the big carbon farming ranch in California, he was really scratching his head over this system, and he was like, well, we're utilizing so little of the land area, if you really think about it. There's all this area right around the stems that isn't being used. So he redesigned the trellises that he was using in a vineyard to be taller and Y-shaped instead of kind of in a single plane, so that the grapes are growing overhead instead of vertically. And then you can just have grazing blocks that are underneath them, and the animals can move in any direction, and it's all grass. And they also feed on the suckers of the grapes. And so there's been some studies on the improved grape production and improved grapevine health and lower disease outcomes with sheep understory management, sheep and pasture understory versus dust understory is what a lot of the conventional vineyards out west use. So pretty cool stuff. You could also imagine silvo vitipasture, where you had occasional interplanted larger trees as an overstory, fodder trees. So check that out if you're curious. I don't know if any of you are grape growers, but I know some people on the Cape are starting to get into grapes, so maybe. Okay, and then some resources, and then we'll take another last few questions and close. So Steve Gabriel's book, Silvopasture. It's the only book that's been written in North America about this topic yet. It's very good. I have a few little essays and graphics and things in it. There's Sproutlands is the new book about coppice and pollarding. Again, it's like an airport book, but really, really interesting to read. We have an online Silvopasture course that's starting February 10th that Steve is running. I'm a guest speaker in it and a couple other folks. You can get in touch with Steve to find out about that. There's also, it's a little inactive right now, but there's a Ning social media site called the Northeast Silvopasture Ning. Some of that's migrated onto the Silvopasture Facebook group, but there are places to find Silvopasture practitioners and talk to them about what they're doing. So we had a meeting at the Drawdown conference this fall on working on regional strategy thinking about silvopasture and tree fodders. And it was very fruitful. We had people there from USDA and from NOFA and from Glenwood and from some of the other kind of farm nonprofits in the Northeast. And one of the things, so what we came up with was some kind of starting working ideas about what a regional strategy would be to significantly boost implementation and kind of some of these high visibility projects. And so one of the things that led to was that we're working on basically a wave of outreach and technical assistance and education over the next 2 or 3 years across the Northeast. So we're aiming to have eventually 6, 7, 8 silvopasture field days per year in the northeastern states instead of 1 or 2, which is what it's been for a while. So NOFA is doing a pasture and silvopasture field day on June 8th in the Berkshires that you can all come to if you're interested. And we've got more that haven't been finalized and scheduled yet. Also including with Joe Orafice at Yale, who's the agroforestry professor at Yale School of Forestry. So there is a thing murmuring and happening in the region around trying to address the big kind of confidence and accessibility gap around this practice and just giving people more chances to come into contact with it. And this workshop being at this conference is part of that. So thanks for participating in the Northeast Silvopasture strategy. And then my colleagues and I are also super available to talk to people and come to your property and look at how to implement some of what we talked about if you're interested. So you can contact us like that. And we've got 2 minutes left for the last burning question, or even a reflection of someone. Yeah.
Ever since Paradise Lot, I've been thinking about how do we do all of these things in the city. And right now, not by preference, but happenstance, I live in the part of Cambridge that has the least trees of any part of Cambridge. And so that's a
great question.
Reflection question.
Yeah, great question. Well, it really is related to the question of how do we do livestock in the city. I think that's the more fundamental question there, is what are urban livestock strategies? And then you can figure out how to add trees to that. But it's kind of like with the grazing. You have to be doing good grazing first, or else there's no point in adding the trees. If you're doing excellent grazing, then the trees can push it even further if you do it well. So, and I saw one here as well. Did you have a? Okay. Yeah, no.
How do you keep the deer from eating the trees?
Yeah, how do you keep the deer from eating the trees? Okay. There's 2 ways to do that. There's 3 ways to do that. Deer. Well, even then, deer fencing is one of them. So if you have other agricultural reasons to have a large area of deer fence, which is real expensive, but people do it, then you don't have to do deer protection inside that fence if you successfully maintain the fence. You have to watch. I mean, I've seen deer crawl through culverts to go under fences. So you got to get real. You got to be as they're always smarter than us, but you got to attempt to be as smart as they are.
Easy hunting.
Yeah, maybe very very good. So another one is tree tubes. So in the world of people who plant a lot of trees, there are passionate discussions about many things. One of the things there are passionate discussions about is tree tubes. And you will find people who hate tree tubes and refuse to use them, and you will find people who are really into tree tubes. I will just fully reveal and confess that I am one of the people who's really into tree tubes. And I have had really good results with them. I like the effect that they have on the growth of the trees, and I find them very simple and practical. So I like tree tubes. Some people don't, and you should learn from both. But tree tubes, do both tree protection and vole protection with one strategy, and that helps with the labor costs of tree establishment, because you don't have to do the hardware cloth protection for voles in addition. So then the third thing is, so even if you have the perimeter deer fencing, you still have to do vole protection around the tree. You still have to do a little hardware cloth cuff around the tree, usually up to 2 or 3 feet for winter vole protection. And then, or you can have individually fenced trees with vole protection for the deer plus the voles. But yeah, it's a whole thing that you got to work out for your site and what you want to budget out those different options and do a little analysis.
Will tree tubes get a tree past the point that it needs protection, or do they grow out of the tube and then you got to figure something out?
No, because the tree tubes are 6 feet tall.
Okay.
So yeah, what I'm talking about is the really short tree tubes. I will never use.
Okay, those are the only kind
yeah.
I've ever seen.
No, I'm really not in favor of short tree tubes because they don't fully solve the problems you're trying to solve with them. But the tall tree tubes that are 6 feet are very practical for deer protection, and we've had a lot of success with those even on pretty large plantings. Okay, and then yes, one last.
Just about the tree tubes.
Yeah.
I don't think I've used those either. How deep underground do they go underground?
Nope, they don't. So
how do they keep the voles out?
Yeah, they keep the voles out because the voles don't go underground either. So the voles go between the top of the soil and the top of the grass with the mulch or the snow. So it's kind of a longer conversation, but one of the things we're trying to do is create opportunities for people to have access to education about tree planting, because that's a whole skill and ability in and of itself. But basically, there's things you do with mulch. There's things you do with how the tree is set in the ground. And there's things you do with the tree tube or the hardware cloth that can protect it. You don't have to go actually into the soil to protect it from voles. In California, you need cages that surround the entire root system to protect them from pocket gophers. So you can be thankful that we don't have that situation. But it is doable. And I know because I've gone back and line checked all of the plantings for several years, and there's vole damage on like 1 in 20 or 1 in 40, and usually it's when the tree tube got knocked over by the wind, and then they can access it. Okay, well, good friends, it's 3:33, so I've kept you much too long. But thank you for coming. Thank you for your good questions and interest.